Hey, what's up guys? I just want to take a little bit of time here. If you're struggling with the concept, dealing with your metric conversions, watch this video a couple times. I'm going to go in some pretty good depth. It's going to go really fast, so if you need to, the way these videos work and how they're going to work throughout this class, if you need to, pause the video. Okay? If not, if you need to, scrub it back. Just slide back some so you can hear me say something again. And if you need to, of course, replay it. This video is here. I don't take the videos down. You can come here and watch the videos as many times as you want. And if you have any questions, of course, you can message me on Remind, or you can also find me at the school. My door will be open in the morning, or find me during lunch or sometime in another, and I'll help you as much as I possibly can. Anyway, let's get started. The first thing you got to make sure you got with these metric conversions is this prefix chart. Okay? Now, we went over this in class. I gave you the prefix chart in class. We discussed the prefix chart in class. I'm not going to use any more time with this video to discuss the prefix chart. Besides, you need to know it. Make sure you know from peta, tera, giga, mega, kilo, hecto, deca, deci, centi, milli, micro, nano, pico, and femto. Make sure you know all of them, the values that are associated with them, and their symbols. You have to know them all, because eventually you're going to get to a part in the class to where I'm not going to be looking at you and telling you that you need to do a conversion. You have to notice that you have to do the conversion yourself. So, to start out, over here I have 4 problems to start out with, and they're different ones, and they're starting from easy and getting a little bit harder, and we're even going to kick it up a little bit harder after we're finished with these problems. So let's just start. And I'm going to do method 1. Okay, so what I'm saying with method 1 is like my method of what I really like to do. I'm going to do method 1 in blue because I like blue. So let's look at this problem here. I have 12.578 liters, and I want to know how many microliters that is equal to. Method 1 says write it down. It's going to be times 10 to something another. So we have to find out what that something another is. And remember how we do that. We take the value, the exponent value from our table. And for the first one, so liters, it's just a single letter. A liters is just a quantity of measurement. It's a quantity of volume. So we just leave it. It's the base unit. So we'll have 0, and we're going to subtract. Now what are we going to subtract? The value for the other unit, which is micro. Okay, so you should remember for micro will be -6 if you need to. Micro, -6. So I'm subtracting 6, which is the same. Subtracting a negative is the same as adding a positive. So I get +6. So 12.578 times 10 to the 6. This makes sense because I'm going from liters, which is a large quantity of measurement, to microliters, which is a smaller quantity of measurement. So the quantity of measurement to decrease, the number needs to increase, and the positive exponent does that for us. Now if you need to, absolutely you can do method 2, which we would take, oh that's black, I don't want to use black, sorry. I had a green marker somewhere. There it is. You flip to the green marker. So we got 12.578 liters, set that over 1, then we're going to set the conversion table next to it. So I need liters to cancel. Liters are on the top, so I need to put liters in the bottom. And I want to be left with microliters, so that's what's going to go in the top. It's as simple as that. What I want left is going to go in the top. What I want to cancel out is going to go to the bottom, because I put what I started with in the top. So now it's lined out here for me, to where what I'm going to have is these liters will cancel. That's good. I want liters to cancel out. Now I have to do some math. Remember what I said in class. What I like to do is, so you don't have to deal with that negative exponent a whole lot, is set the largest quantity of measurement into my conversion factor equal to 1. And then the other one's going to be 1 times 10 to the something another. So you have to find that something another. So to find that something another, you're using the same process as method 1, as I said before. So we're starting with liters. We're going to start with that, and we're going to go with 0, and we're going to subtract from it the micro. So minus, and the micro is just -6. Why I keep saying about method 1 is because you literally just did here what we did up there, but you're not showing all that math behind it, all this filling in right here. And I'm okay with that to start out. We're not doing mole conversions yet or anything like that, so it's okay. I don't want you to waste a lot of time with this. Now, if you do this, you're going to punch it into a calculator. And remember, on your calculator, you want to set it in scientific notation the correct way on your calculator, which this is how I do it. I do parentheses 12.578 in parentheses. I'm going to multiply because they're both on the top. Parentheses, 1 second function, comma, which gives me the e, which I'm looking for. Then that e takes place of this times 10. So I just write the exponent of 6. So I write that in there, I in parentheses, and I hit enter, and I end up with a 1, 2, 5, 7, 8, 0, 0, 0. So 12,578,000 microliters. Now the thing about this is, I know what you're thinking, Mr. Hall, your numbers are not matching up here. Actually they are. All this is a way that we've just got factors of 10 here. If you would multiply 12.578 times 10 6 times, what you're going to end up with is 12,578,000. Okay, so with that, work whatever is best for you. I'm not concerned with if you can put it in this terminology for me. I don't care about that. Why? Your calculator's not caring about it. What I'm caring about is you can do these conversions so later in class, whenever we start building on top of that topic, you're not falling behind. So make sure you can do this problem. Make sure you feel good about it. Okay? So here's what we're going to do. We're going to move to this next problem, which is right here. Okay? 78.6 nanometers equals how many meters? Now please notice something I did here. I did this on purpose. That's right, I did this for your help. Look what's sitting here. There's just an M. That does not stand for milli. Okay? A letter by itself is a base unit. So, M. M stands for meters, so we're just going to do a straight up standard conversion. Yet again, I'm going to use blue for method 1, and I'm going to write down 78.6 times 10 to something or another. I got to figure out what something or another is. So I have nano. I'm starting with nano, and nano is -9. And I'm going to subtract from it whatever meters is. Remember, meters, it's by itself, so it's the base unit, which is to the 0 power. So, -9 minus 0 is -9. We're done. There's your answer. Okay? If you want to do method 2, I'm just going to set it up. I don't feel like punching it back in the calculator. It's going to take more time. But I'll set it up for you, so it's 78.6 nanometers over 1. And the conversion factor, where do I need to put my conversion factor? What does it need to be? Hopefully you know by this time it needs to be meters over nanometers. Why? So that nanometers are canceled and meters is left, which is what I want. And like I said before, let's set 1 to be with the largest quantity measurement. A meter is bigger than a nanometer, so we're going to set 1 there with meter. And nanometer will be 1 times 10 to something or another. We're going to do the same thing we did before. We're starting, so we're starting with a meter. So a meter, we're starting with 0. We're going to subtract whatever the other one is, and it's nano, so it's a -9, so we're going to subtract a -9, which will be equal to a 9. And I know what you're thinking. Mr. Hall, that's not what we got up top. The reason it's not what we got up top, this is different. This is up in the numerator, that -9. Remember how I talked about that math concept in class and how this thing's working out here. This is down in the denominator. Here, take your calculator if you don't believe me. Set it in right. 78.6 divided by 1 times 10 to the negative, 1 times 10 to the 9th. Sorry, 1 times 10 to the 9th. If you do that, you'll end up getting 78.6 times 10 to the -9th. Or you'll get 78.6 divided by 10 9 times. Either way. Okay. I'm not going to punch in a calculator. From here on, I'll just set it up. I'm not going to take that time to do that. Okay, if you have questions on these, come to class with questions. I'm fine with that. Okay, so let's go over here to this next problem. Over here, we've been going from a prefix to the base unit, or the base unit to a prefix. Now we're going to go from prefix to prefix. Okay, it gets just a little bit harder, but still the same concepts stay the same. So 29.8 milliliters equals how many gigaliters? That's right, you're guessing it right. 29.8 times 10 to a something another. Let's find out what that something another is. The something another, we're going to start at milliliters. Remember, take it down as it is on the chart. So -3 minus whatever giga is. Hopefully you're remembering and getting used to it by this time that giga is the 9. So -9 equals -12. And if you want to set it up for option 2, it's 29.8 milliliters over 1 times the conversion factor. Okay? If you want to set this up yourself and try, you need to hit pause now. Hopefully you're getting a feel for how to work with the videos. Alright, I want gigaliters. Oh, that looks bad. Left, so gigaliters on top. I need milliliters to cancel. I put 1 with the gigaliters, and I want with milliliters 1 times 10 to, that's right, it should be the 12. Okay? Hopefully you're getting a feel for this. I'm not going to punch in the calculator again. If you need to, go ahead and do it. You should still come up with that top answer up there. Alright, going down here to the second one. 168.12 gigapascals equals how many micropascals? I use this as an example for a purpose. I have a question for you. Do you have any idea what a pascal is? Do you have any idea what we use pascals for? Does it matter if you can answer either one of those? No, it does not matter. Because what matters to you is right here. Giga and micro. The pascals stay the same. I'm asking you to do a metric conversion. I'm not asking you to change nothing major. I will throw units at you like this that you've never seen before, and the whole reason I do that is to try and catch you off guard. Okay? Don't let me catch you off guard. Don't let me intimidate you and scare you with this problem. Take the time. It's as simple as this. Do what you did up on the other problems and how we worked every other one. Write down the number before. 168.12 times 10 to a something another. Find out what that something another is. Okay, so we have giga. You look at it, what's giga? Okay, giga is 10 to the what? That's right, 9. So here we go. We're going to do a 9 minus, what's micro? Sorry. Okay, subtract it out. What's the micro? -6. So it's like adding it. So it's like adding that positive 6, so we get 15. So it's 168.12 times 10 to the 15. Setting it up again, I'm going to set them up a little bit faster so I can roll through this video a little bit quicker. So 168.12 gigapascals, and I'm going to use a conversion of, I want micropascals, so micropascals go on top, and on the bottom we're going to put gigapascals. Set 1 with the gigapascals, so 1 times 10 to the 15th will go on the top. Okay? I know I did that one really fast. If you need to, just pause the video, try it yourself. If you're not understanding, come to class and ask me about it. Alright, we have plenty of time before we're going to have to worry about anything. So, hopefully you're good there. Alright, give you a moment if you need copying this down. Now's the time to pause it because I have to erase it to write some more problems. Because, yet again, we're going to pump it with some more steroids. Let's give it a little bit more complexity here. Okay, let me write some problems down. If you want to, you can scrub the video forward, save you some time here. I don't know, let's just pick some 112.64 times 10 to the 6, and we're just getting hard here. Let's keep it hard. So let's do I don't know, some terabytes is equal to how many? Let's just have a little bit of fun with it. What do you say? Let's do nanobytes. Why not? Yeah, man. Okay. And then let's do something else like that. Kind of looks intimidating. I'm setting it up like this so it looks intimidating for you. 6.294 times 10 to the negative. Let's do a big number. 64. And we gotta go from this end. Let's do pico. I'd really like some pico de gallo today. So let's do candelas. So pico candelas equals how many? Go to a higher number. Let's go to mega candelas. Combining two things that look intimidating and a little hard, but shouldn't be that bad for you. Okay, I don't want you to get intimidated by this. Just take your time. Okay, this problem right here looks intimidating. The reason it looks intimidating, I understand and I know why. Because, oh my goodness, all of a sudden I had this exponent to start with. All it is just a little different of a way. You're going to do everything you've done so far, and we'll take care of that exponent in a new step. So here's your new step. Do what we've done so far. Okay? So 112.64 times 10 to a something another. Do what you've been doing. Find what the something another is, but we're going to add one more step to it. So we're going from tera. Okay? So from tera, we have to remember that tera is 10 to the 12th, so it'll be 12 minus whatever this nano is. Hopefully you remember by this time that nano is to the negative 9. Okay? So you'll go from there, and you'll find that it's 21. This is not your final exponent. This is another little trick Mr. Hall likes to throw at you. Okay? I'm going to write this in purple because hopefully you've learned by now if it's in purple, it's important. So, in this, I have 21. It doesn't matter what number you had at that point. What that change in those prefixes are, that's all I've done is found the change in the exponent for the prefixes, and all I have to do is add that with that exponent I started with. So let's add 6. Why? Because we started with that. So it's equal to 27. Okay? Now if you go with method 2 here, it's not going to be that bad. You're not going to have that extra step because you are going to take care of that exponent starting off right here. When you do the 112.64 times 10 to the 6 terabytes. You're going to set that over 1, and you're going to multiply it, nanobytes on top, and terabytes on the bottom. 1 terabyte, because terabyte is a large quantity measurement, and that's what we want. So 1 times 10, and you look and say terabytes. Okay, a terabyte is 1 to the 12th, so it's 12 minus nanobytes, which is negative 9, and you find that to be 12 plus 9, which will be equal to 21. Now in this, terabytes cancel out, you do the math, you go straight across, you're going to find out that you'll end up with that answer up there. There's not that extra step. You only have that extra step here that I wrote in purple if you do method 1. Hopefully you're feeling good. I know that one looks a little complicated. Follow the steps. The important thing of it is you get the steps down. Don't think about memorizing the problem. Memorize and learn the steps. If you learn the steps, you'll be fine to just keep applying it. Okay, this one looks really scary. I set it up like this way for a reason. I really wanted to show you that I'm going to really try to intimidate you on these. So, I'm going to do it with purple marker. I'm doing great at losing my markers. Fantastic. There we go. I got all sorts of power. Okay, just like we did with the Pascals, that PA from those problems before. Here we have the same setup. We have a C and a D. Don't be intimidated by it. Candela stays the same. What are you focusing on? That's right, pico and mega. Just focus on that. Don't worry about that other stuff. You look and say, oh my gosh, that's a negative 64, Mr. Hall. That's big. Who cares? Follow the same steps as you did up here. So, go with how you've been doing. Write the number down. 6.294 times 10 to something another. Find something another out. So we're going to start here with pico. What's pico? Man, hopefully you're getting good at it. Okay, it's negative 12 minus mega. What is mega? 6. Okay, because it's 10 to the 6. Negative 12 minus 6, negative 18. Same process you've had so far. Just with the added step, because we have this exponent now, we're going to add this step right here to it. So we're going to add a negative 64. You're going to find that to be, I'm going to do a calculator because it's been a while since I've done some math like that. We've had a good little summer here. Let's do 18 plus, so 82. So you'll find that to be equal to negative 82, and it's negative because they're both negatives. So let me finish writing that one out right here. It's not too bad. Okay, hopefully you're not intimidated by that. That's not my goal. I don't want you to be intimidated by these problems. I want you to feel encouraged, feel like you have a chance. Now, I've done a couple of these. We're going to do some more in class whenever you guys get back. We're going to focus on more, and we're going to step them up again. And what I'm saying by step it up again is we're going to take and we're going to do some area and some volumes. So what I'm saying is, like, we're going to square our units and cube our units, but whenever we get in class, I'll focus more on that because I know that can be a little frightening more. So if you guys have questions, come find me, come ask me. If not, I'll see you in class.